Sir,
Yeah, please.
sir, can you share the this PPT?
PPT, yes. Now it is not required. Then when it is required, I am providing the PPT also and the material also. You don't worry. Okay. But
Thank you.
remember one thing, this is not a theory type of subject. I'm not providing any notes and all those things. You can ask the your seniors. Okay, I'm not giving any particular notes. Okay. But remember one thing, if now it is online is going on, so if it is required some particular person, then because we are discussing all the problematic type of question, yeah, problem. Okay.
Okay,
So how to design the circuit and so it is not theory, and when it is required, then I will provide the material. You don't worry about that. But your main target, your primary target is that you can follow the textbook. It is very necessary, very necessary. Okay. Without the test, because I'm not discussing all the examples in the class, online class. Are you getting my point? So I'm providing 2-3. I'll discuss 2-3 example or 2-4 examples, and after that, similar type of example, solve an unsolved problem you are getting from the textbook. So from there, you have any doubt, then you can ask me. Are you getting my point?
yes,
so you can just how I exactly I have maintained the class in the last semester or last year. You can ask yes your seniors. Okay, they will help you, because I'm not exactly providing the notes, because I'm just discussing, and if it is somehow it is necessary, then I'll provide. You don't worry. Okay. Okay, and one thing, I'm starting this particular lecture too. Just remember one thing, your microphone must be off, and when any doubt, please on your microphone and you can ask me anytime. Okay, it is not like that, sir bol rahe hain, abhi mujhe baat nahi karna hai. This is not like that. When the class is going on, that time also you can stop me and you can ask. Okay. Okay.
Yes, sir.
yes, sir.
Just provide the response, otherwise I am not getting, because I am not very much yeah, because we are starting last semester the online class. So if you are keep silence for few minutes, then I feel something is I feel yeah, some type of different. Okay, so you just give me the response. Okay.
Okay, sir. Yes, sir.
So today I am discussing the and the yes. Just you remember one thing, tomorrow, according to the class timetable, your class will be started from 10 to 11. But problem is that today I have some particular work, so I am taking only 1 hour class. And tomorrow, though class will be started from 10 to 11, but tomorrow I will start from 9 a.m. to 11 a.m. Okay, instead of 10 a.m., I will start 9 a.m. Okay. And tomorrow, just today, I am taking only 1 hour, because some particular moderation and all those things are there. So I have completed. I will complete that particular task. Okay. So today we are discussing number systems. Okay. Now, why number systems actually required? So yesterday we are discussing about the digital electronics, and we are discussing the analog circuit or digital system or analog system, or you can say digital circuit and analog circuit. Okay, no problem. But you also know what is the difference between the analog and the digital circuits. Now what happened? Actually, why number system is very much important. Before we are moving to the another topic, if your numbering system is not clear, that time what happened? You cannot design, you cannot go in digital electronics, or you cannot manipulate, or you cannot design the digital circuits. Okay, so why numbering system is required? It is very simple, because when we are using the digital circuit, that time what happened? Two voltage level we are using. That means digital circuit only produce the two voltage level. One is called a 0 and one is called a 1. And 0, 1, basically we are using the binary numbers. And why it is binary numbers? Because computer understand only 0 and 1. I'm not going for assembly language, machine language, and all those things. When it is required, then you can automatically understand. Now, so then how it is related to voltage level 0 and 1? Because this is the number system. Then what is the relation with 0 and 1? Because I have already discussed, because you can design one particular digital circuit. Okay. Now what happens? Correctness of that particular circuit, you providing some particular input. And now what happens? Based on that particular input, some particular outputs are generated. Now, then obviously, when you are designing one particular circuit, then if you are using some particular input, then obviously based on that particular input, some outputs are produced. So how we can control that particular output? That means all the outputs are not required. Some particular specific outputs are required. Okay. So that input exactly working based on the what type of function actually, Boolean function actually you are using. So what happened? Before we are providing the input, we are expressing the Boolean function. Based on the Boolean function, that means Boolean function means what? It is the one type of behavior of that particular circuit. Okay. So when based on the Boolean function, when you are providing the input, and that time what happened? Outputs are generated based on that particular Boolean function. Okay. Now I'm going to the Boolean function, but here it is number systems. And then what is the number systems? So number systems actually coming because digital electronics only two levels, 0 and 1, or you can say binary number 0 and 1. So different type of some particular numbers we can use to manipulate or operate that particular circuit. Okay. So what happened? There are different type of number system introduced in digital electronics. Okay. So because what happened, input always provides some particular numbers. Okay, maybe it is binary numbers, it is okay. But what happened? Binary numbers actually we are not using all the times. Because what happened, the sequence of 0, 1, 0, 1, 0, 1, 0, 1, something, it is very complex for the users or for the designers. Okay. So apart from that, how to manipulate the 0 and 1s, some particular extra numbering system we are introduced. So this particular number system, before I am discussing, you already know in the class 12 standard or some particular, because you are familiar of the number system, but what happens, some particular new concept maybe we will discuss. Okay. So what happens? What is the number systems? Number system means what? It is systematic way to represent and manipulate numbers. Okay. Because what happens, if you are because what happens, digital circuit always performs the behavior, and behavior is generated the Boolean function, and how that particular Boolean function actually work, we are providing some particular inputs, and that particular input may be a number system. So what happens, number system actually generated some systematic rules and manipulate the numbers before we are designing the digital circuit. Okay. Some of example of number system are decimal numbers, Roman number system, binary numbers. Okay. So apart from that, there are different type of numbering systems are there, hexadecimal, octal. Okay. So different type of numbering, coded number also there, BCD, binary coded decimal, gray code, access tree. Okay, that particular part we will discuss later, one by one. Okay. So what happened? Now here I am using only 3 numbering system for the time being. Decimal number system, Roman number system, binary number system. Decimal number system means what? Can you tell me, anyone? What do you mean by decimal number systems? Anyone?
Sir, base 10.
The values of
Base 10.
Base 10.
See, when I am asking something, and also this particular portion you must be remember. When I am asking something, and when I am providing some particular question in the sessional, in the internal exam also, in the end semester also, in the mid semester also, you can write to the point. Okay. So I'm not asking about the base or something, but I'm just asking what do you mean by decimal number? And whatever you are providing, few seconds, that means if I'm asking what is the base of the decimal numbers, what is the radix of decimal and a decimal number, then you can say that 10. Just I'm asking what is decimal number. That
so
means,
the commonly numbers, the
what do you
commonly
mean
used
by
numbers
the,
which we use, like 0 to 9 and so on.
what is your name?
Sir, Ashwala, sir.
Very good. Very, very good. Yes, that is the correct answer and to the accurate answer. Okay. Decimal number means what? whatever we are using normal, that means in mathematics also in normal day by day working, what type of numbering is now, what type of number we are using, that particular number is called a decimal number. Okay, for a time being you can forget about the systems, because what happen, decimal number also we are using in system. By binary numbers I am also using the system, but obviously Roman number we are not using in the system, but for example purpose I am using the Roman number system. So decimal numbers actually we are representing 123.56 or 324.67. For 0 to 9, all the numbers are called a decimal number. Okay, so what is the meaning is that the combination of 0 to 9, any combination in the range between 0 to 9, we can construct any particular number, normal numbers. Okay, now what happened? Roman number, Roman number, something we are using Romanian. See here I am providing one particular example, IV. So IV means what? 4. When we are converting to the decimal number, it is representing as a 4. If I am using I, symbol I, after that V, that time what happened? It is representing as a 6. Okay, so what happened? Which particular it is V? I is we are using before V or after V? Okay, that is depends. So VI, and if we are combining with XIV, then it is representing 14. So this is also one type of numbering system. But what happened? We cannot set any particular rule here where when it is IV, when it is VI, and when we are, if I'm using IVX, that time what happened? So what happened? We are not setting any particular rules. So what happened? Roman number also one type of numbering system, but there are no particular specific rules we are providing in Roman numbers. So Roman numbers actually we are not using in digital electronics. For example purpose I am using. Okay. So, and we are using 0 to 9. If you are counting from 0 to 9, then how many total numbers are there? The occurrence of numbers 10. 0, you can count from 0 to 9. It is total is 10. So for that particular purpose, the base, and why base is required, I will discuss later. Base means what? It is actually if some particular writing, suppose I'm writing 10 within bracket 10. So automatically you can understand this particular 10 is a decimal number. How? Because base is 10. Are you getting my point? So what happened? For representing any numbers, we are providing some particular base. And when we are manipulating that particular number, we are using the base. Or you can say that radix. Radix also, you can call base, and alternative name is radix. Don't confuse this one. Okay. So see here, I'm using 258.36. This particular right hand side portion, for a time being, please stop this one. Just 258.36, one type of decimal number. Okay, after decimal point, here we are providing 36. So 258.36 also one type of decimal numbers. Okay, and see here Roman number IV equal to 4, VI equal to 6, XIV we can representing as a 14. Now binary number system, it is very important because you know already binary numbers we are using in digital electronics. The most of the cases that generally we are using this particular binary number system. So binary number system, what? It is the sequence of 0 and 1. Any sequence. Okay. Suppose example is that 0101.001. So after point this is the called a fraction part, we are 001. And how we are converting the conversion procedure to binary to decimal, decimal to binary, binary to hexadecimal, binary to, but Roman numbers actually we are not using. So for the timing, just you can stop this one. So and all other numbering system we can convert each other. Okay. And apart from the hexadecimal, you can also know one particular numbering system here. Though I'm not writing here, one particular number system is called a hexadecimal number. So what is it is very uncommon numbering system, but people are daily use that particular number. So suppose example we are using the clock, our watch. That means whatever clock we are using. So what happened when the 60 second is coming? 60 second it is completed. That time what happened? It is convert to the 1 minute. So what happened? What is the counting? 0 to 59. So what is the total numbers are produced? It is 60. Okay. So that type of numbering system is called a hexadecimal numbering system. Hexa, not a hexa. Hexa. SEXA. So, but numbering system based on some particular properties, numbering systems are classified in two types. One is called a weighted and another is called a non-weighted. Now, I'll discuss this one, weighted. So weighted number generally decimal number, binary number, octal number, hexadecimal number, all are belongs to the weighted numbering system. Now non-weighted means what? Roman numbers, because there are no specific rules are there. Gray code also, they are not particular, we cannot directly manipulating, but some particular rules are there, but we are not providing any type of weight of that particular number. Gray code or access tree, these all are the called a non-weighted number. Okay, suppose what happen, why decimal is called a weighted number? See here, I am providing one particular example, 258.36 equal. You can see the right hand side of the equal symbol. Here I am using 10. See here 2 into, if we are going from right to left, see here 2 into 10 to the power square plus 5 into 10 to the power 1 plus 8 into 10 to the power 0, like that. Okay. Now what happens? When you are writing this particular number, always we are counting from left to right. But remember one thing, the fraction part we will manipulate it in different way. Before fraction part, we are counting from not a right to left, not a left to right. Okay. So see here, before decimal point, the number is 258. So what happens? Each particular bit position, each particular number have a carry some particular weight. So we are starting from right to left, we are starting from 0 weight, 1 weight, 2 weight, like that, 0, 1, 2, 3, 4, something like that. And why I am using 10 to the power something, because you know decimal numbers base is 10. Okay, so here what happened, what we are using 8 into 10 to the power 0, 5 into 10 to the power 1, 2 into 10 to the power square. Okay, and plus after decimal point, see here something is different. We are counting from left to right, and instead of some particular positive integers to the power of 10, we are using minus. So what happens when the number is increases from left to right, we are increasing our power, but before power we are using the minus symbol. So here 10 to the power minus 3 into 10 to the power minus 1 plus 6 into 10 to the power minus 2 something. Oh, sorry. Here it is. Here it is. Yes, it is correct. Something like that. Minus 1, minus 2, something like that. Okay. And when we are adding, whatever the values are generated after multiplication, we are adding, we are summing all the numbers, and we are getting the 258.36. So this way, if you are binary numbers also we are defining, so we'll discuss later that one. So we are manipulating the numbers based on some particular way. So decimal numbers also, so decimal numbers is called a weighted number. And binary number also we can do that, this one. Okay. So for this particular portion, you have any doubt? Do you have any doubt?
No, sir.
Sir, student is trying to join from the 6 minutes. He's unable to join.
Pardon?
A student is, yeah, so a student is trying to join from around 10 minutes, but he's unable
because
to join.
I don't know, because I'm opening my PPT and I'm not getting. Okay.
Oh, okay, sir. Okay, sir. Okay, sir.
Just a minute. Just a minute. Okay. Okay. Anyone is there? Okay. Okay. Yeah, PPT is visible. PPT is visible.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Okay. Okay. Now, for this particular portion, you have any doubt? And remember one thing: when I'm discussing when I'm presenting the slide and all those things, then just you can keep your notes and pen with you. Otherwise, what happen? Don't use the shortcut. If suppose what Sarne is just you can clipping snapshot is not a work actually. Okay. So suppose what happen? I'm using 258. These are very basic, but remember one thing: basic is sometimes is very difficult. Okay, your concept is not clear for decimal this conversion or what is the decimal number system, binary number system. That time what happened? you digital circuit, the design of digital circuit you forget about. But how you can manipulate the Boolean expression, logic expression, how you can design the Boolean function, that particular portion you cannot understand. So numbering system is very important. Yes, please.
Sir, the PPT is not visible. I mean, it was visible, but I don't know what happened. It is not visible now.
Okay, just a minute. Now it is visible. Now it is visible.
Yes, sir.
Okay.
It is visible.
So yes, this one, this is the difference between the weighted and non-weighted number. Any numbering system, we have to follow some particular properties, and the numbering system we are followed one particular properties, that is called a weighted and non-weighted. Okay. So this is the So next one is that the basic concept of numbering system. Suppose if we are discussing the decimal number system, though you have to understand this because this is the very basic. You have class 8 or 9. You can this particular portion already you know, but it is some particular because we are using phrase. So just I am giving some particular hint. So decimal number system, the total now 10 numbers. Whatever you are saying, one particular students are saying 10 numbers. It is correct. So whatever 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are representing. Okay. So I'm talking about only decimal number system. Every digit position has a weight which is a power of 10. So whatever remember, so power of 10, and when we are manipulating the decimal numbers, we are using the base is 10. Okay. And why it is, if someone is asking why it is 10, because we are using the 10 numbers 0 to 9. So base is 10. And see here, base or radix of decimal number system is 10. See here how we can representing 367. So here 3 numbers are there. So we are starting 10 to the power 0 into 7 because most right hand side is called 7. So remember what happened? Leftmost side and rightmost side are some particular LRS. That particular portion we will discuss later. Okay, no problem. So 10 to the power 0 into 7 plus 10 to the power 1 into 6 plus 10 square into 3. So total is 367. Okay. And if we are 522, so see here, so fraction after the decimal point, this particular fraction 3 into 10 to the power minus 1, 5 into 10 to the power minus 1. So this is the basic introduction of decimal number system. Okay. So next one is say binary number system. Okay. So you already know binary number system, we are using only 2 digits. But remember, this is not exactly digit, this is the number, binary number, 0 and 1. Okay. So again, same thing, every digit position, instead of 10, in decimal number, we are using the weight 10. Here we are using weight is 2. Because why it is 2? Because we are using only 2 numbers. Okay, 0 and 1. So total, if we are finding the cardinality is 2. So what happened? So we are using the base is 2. And when we are manipulating the number system, that time what happened? We are using power of 2. Okay, so base or radix. Radix and base are same. Sometimes it is called a radix. Base or radix of binary number system is 2. Okay. So see here, 1010, this is the sequence of combination of 0 and 1. So how we are converting to the number? So see here, 2 to the power, yes, this is the 2 to the power 0 into 0 because the most right hand portion is 0. And after that, we are going from right to left. Next one is 1. So 1 into 2 to the power 1 plus 0 into 2 to the power square. So total is what? It is 8. And this one is 2. So it is 10. Are you getting my point? So 1010, it is representing decimal number is 10. And same thing, if we are using the fraction 110.10, that time what happened? The same thing we are using, but we are using the minus 1 in the after decimal point, and after that minus 2 it is bit. When the number is increases, that way we are going minus 1, minus 2, minus 3, minus 4 like that. Okay. Any doubt this one? All are getting?
No,
No, sir.
Yes, sir.
Someone is saying no. Oh, no. Yes, please. Any doubt? Then please ask me.
So can you tell it for me once again?
Okay. So see here, in binary number system, we are using only two numbers. What are the two numbers? 0 and 1. So it is called a binary number. And sometimes it is 0 means what? Sometimes it is low voltage, and sometimes it is representing false. Okay. Or sometimes it is called a low, false. Some particular keyword we are using, which are representing is 0. And 1 means what? It is high, true. This type of keyword we are representing. Okay. So basically what happened? We are using only two numbers. So base is the cardinality of the number is 2. So we are providing. So we can say that we are using the, what is the base of radix of binary numbers? Binary number is 2. Okay, number 2. And when the binary numbers representing, or when we are converting binary numbers, or when we are manipulating the binary numbers, that time what happened? We are using the base. Okay. So here see example, the last point we are providing some example. I am providing some example 1010. So what happened? How many? What is the length of this particular sequence? 1, 2, 3, 4. So we are going from 0 to 3. So 0 to 3 means what? 2 to the power 0, 2 to the power 1, 2 to the power square, and 2 to the power cube. And next particular example, see here 110.10. Before fraction part, we are using how many numbers? 3 numbers. So here I am writing 2 to the power 0, 2 to the power 1, and 2 to the power square. And after decimal point, only two particular numbers are there. But here, some particular representing is something different. We are using -1 to the power -1 into 2 to the power -1. Are you getting?
Yes, sir.
Yes, sir. Yes, sir.
So this particular portion is clear?
Yes, sir.
Clear, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So now, any per weighted number, see here, the representation of numbering system, digital decimal number, binary number, octal number, hexadecimal number. So what happens? Some particular general formulation is required. Okay, though representing is something different, but we are using the same concept. So this is the general formulation to representing the numbering system with radix or base. Okay. So here, suppose what happened? Radix is nothing but a base. Okay. Suppose here we are using small r, which are representing the radix. So that means what? It is, the meaning is that number of distinct digits based on the numbering system. Suppose if I am using the decimal number, that time what happened? Distinct digit is what? 10. If I am using the binary numbers, so distinct digit is what? 2. If I am using the octal numbers, then the distinct digit is 8. If I am using the hexadecimal numbers, then distinct digit is 16. So till now we are not discussing octal and hexadecimal. You don't worry, we are going that one. So what happened? We are assuming that particular digits are 0, 1, 2, dot, 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 comma, within bracket r minus 1. We are starting from 0, the ending we are going r minus 1. This is the first point. Second point is that every digit position has a weight, that is some power of r. Okay, so suppose here we are using some power of r means what? Here suppose what happened? The power we are representing as a k, small letter k. So you know any particular number system, whatever till now we are discussing, there are two particular parts. One is the fraction, that means one before decimal point and after decimal point. If I am using the integer part, that means decimal point, time what happened? The power, the power representing k, small letter k, always equal to 0 or greater than 0. And before decimal part means what? It is the integer part. And after decimal part or after decimal point, this is called a fractional part. K is less than 0. -1 is the less than 0. -2 is less than 0. Something like that. Okay. Now what happened? The third point, if total is yes. At first I completed this one. Then you can ask. Okay, just a minute. Just wait for a few seconds. So n plus m. N plus m. N plus m is the length of total digit numbers. Okay, the total length. Suppose m here representing the fractional part and n is representing the integer part. That means what I mean to say, that any particular numbering system, the integer part, the combination of integer part and fraction. So d is the number. Suppose capital letter D is the number, and equal to, we are representing d n minus 1, n minus 2 up to d0. Because see here, for integer part, k value is always equal to 0 or greater than 0. So that particular condition, constant is satisfied or rule is satisfied. And after that, k less than 0 means what? It is the fractional part. So we are representing -1. You cannot use 0, d0 after fractional. Now that means when we are using when we are constructing the fractional part. Because d minus 1, d minus 2, d minus m. So it is fulfill the constant of k less than 0. Okay. So what happened here? Excuse me. So what happened here? So how we are representing k? So d n minus 1 means what? So it is r n minus k. R to the power n minus k, 1. When we are representing d n minus 2, that means what? D into r n minus 2. R means what? Radix or base. If we are using decimal, that time what happened? Instead of r, we are using 10. If we are using binary, instead of r, we are using 2, like that. Okay. And when we are going, suppose d1, that time what happened? d1 into r to the power 1. So that way d0 into r to the power 0. And when we are going fractional part, d minus 1 means what? D, the position of that particular digit, d minus 1 into r to the power -1. D minus 2 into r to the power -2. Something like that. And lastly, d minus m, that means I'm using the subscript d minus m into r to the power -2. So this is the general formulation or general rule of any radix based numbering system. Now, please, you can ask any, if your concept is not clear and if you are facing any doubt, then please ask me. One by one.
So what is the highest value, negative value of k? Means backward -2, -1 like that.
So it is depend upon to the how many, yes, it is depend upon to the how many numbers you are using. After fractional, how many numbers actually you are using. Suppose you are using 35.677778. Suppose you are using the 8 numbers, that time what happened? It is going -1, -2, -3, -4, -. It is depend upon how many fraction numbers actually you are using. Okay. Now, yes, anyone can ask me any question? Anyone?
No, sir.
मैं तो अभी खोलना पड़ेगा इसको. अच्छा, ये क्लास रिप्रेजेंटेटिव कैसे क्या नाम है? राजन ना समथिंग? राजेश क्लास रिप्रेजेंटेटिव
Rajesh sir.
और राजेश राजेश ना फर्स्ट नेम इज राजेश ना?
Raj, sir. Raj.
Rajan. Raj. Okay, Raj. Raj, you can please Raj, you can किसी का एक नाम बोलिए, आप लोग का स्टूडेंट का कोई एक नाम बोलिए, कोई एक स्टूडेंट का नाम बोलिए.
राजश्री ग्वाला सर.
राजू मेहता.
जस्ट वेट, मैं उसको ही सिर्फ पूछ रहा हूँ. ओके, तो किसी स्टूडेंट का आपने नाम क्या बोला? कोई एक स्टूडेंट का नाम बोलिए.
राजश्री ग्वाला.
अच्छा, राजश्री ग्वाला, आर यू देयर?
Yes, sir. Yeah.
Okay. Now you tell me one thing.
Yes, sir.
Anyone not asking this particular one? Why I'm using r minus 1? The first point, assume the digits are 0, 1, 2. Why I'm going only r minus 1? What is the concept behind this?
Sir, because for suppose decimal the okay, I'm answering, I think.
जिसको पूछ रहा हूँ वही बोलिए.
Yes, sir. So since we are using, sir, for example, for decimal system, since the base is 10, so the numbers are actually from 0 to 9, not actually 10.
Okay. And when we are going for binary numbers?
So in binary numbers, the thing is we're using 0 and 1, and the base is 2. So 1 is actually r minus 1, that is 2 minus 1.
Okay. That means what? 2 minus 1. So 2 minus 1 is what? 1. Only 1 is left. So the range is 0 to 1.
0 and 1, yes.
So yes, this is correct. And all of you getting this one. So small things, your concept must be clear. Okay. Though it is very small, but your concept must be clear. Okay. So this one. So see here, binary to decimal conversion. How we are going binary to decimal conversion? So each digit position of a binary numbers has a weight some power of 2. Okay. So what happened here? Suppose a binary numbers denoting as a capital letter B, and we are going the two parts. One is fractional. It is denoting from left to right n minus 1 to B0. This is called an integer part. And fractional part is we are ranging from minus m. That is, its range is minus 1 to minus m. And BI are the binary digits. Okay. So BI the binary digits. So what is the general formula? The decimal value. Decimal value general formula is summation of all the binary numbers. Okay. And we are going from minus m to n minus 1. The total length is n minus 1 to minus m. Initially, we are starting from minus m because we are scaling the number, not a left to right. We are scaling the number from right to left based on the weight. Okay, so initially I value is minus m, and what is the upper bound or upper size? Upper size is n minus 1. So we are, and this particular summation symbol means what? We are summing the two binary numbers. Okay, so summation in between bi with 2i. So bi means what? It is the range is what? It is minus m to n minus 1. Okay, and based on that, we are using the power of 2 to the power I. This is the general formula how we are converting binary to decimal. Okay, this is the conversion of binary to decimal. Suppose we are taking some particular example 101011. So what is the range? Now here range is 0 to n minus 1. Because this is only the integer part we are considering. No fraction part is there. So we are not using minus m. So based on this our general formula, so 0 to n minus 1 we are considering. And after that what happened? We are scaling from right to left. So how many numbers are there? Binary numbers. How many binary numbers are there? 101011. 6 binary numbers are there. So we are starting from right to left, and we are using 2 to the power 0, 2 to the power 1, 2 to the power square, 2 to the power cube, 2 to the power 4, and 2 to the power 5. And see here, if I'm using 1 into 2 to the power 0 means what? 2 to the power representing 1. 2 to the power 0 means what? It is 1. Okay. And 2 to the power 1 into 1 means what? 2. 2 to the power square, 2 to the power 2 into 0 means what? It is nothing. It is 0. That means 2 to the power 2 is 4. 4 into 0 is 0. This way we are getting the value is 43. And when we are getting the 43, how we can represent it? This one is the second point is very important. The binary numbers we are denoting within bracket 101001, we are using the base. And base always we are writing not a superscript, it is the subscript. Okay, and when we are converting this particular binary number to the decimal number, then again you can write this is the standard format. You can use within bracket 43, and 43 is, it is what? It is hexadecimal number, or it is octal number, or it is binary number. So
Decimal, sir.
automatically we can
Decimal.
introduce it on the base. So here base is 10, so it is the decimal number. Now see the second point, the second example, I'm using the fractional part only, 0.1011. So here what happened, how many numbers are there? Binary numbers 1, 2, 3, 4. So we are moving, someone is asking me, so how many, what is the range? So range depend on how many numbers actually you are using. So in this particular example, we are using only 4 binary numbers. So we are going 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3, and 2 to the power minus 4. There is no limit. Totally it is depend on the how many binary numbers you are using. If you are using 8 binary numbers, then we are going minus 2 to minus 8. Okay. So when we are adding all the binary numbers, that means bi to the power I. This one is the 1 is called a b, 0 is called a b, b1, sorry, 0, 1, 2, 3, it is called a b3. This one is called a b2, 0 is called a b2, 1 is called a b1, and again 1 is called a b0. So here, see here, we are representing summation of I equal minus m to the minus m to n minus 1 bi to I. So what happened here? So see here, bi. So first weight is because this is the fractional part. We are not going to the left to right. Right to left. We are going left to right. So it is what? This one is the bi is 1. So we are using 2 to the power minus 1. Second one is 2. So we are going to the power minus 2. Something like that. This is the fractional part. And when we are adding all the bi to the power 2i, that time what happened? We are getting 0.6875. And how we are representing this one? This one we are representing 0.100 base 2 equal to within bracket 0.6875 base 10. That means we are converting, successfully converted binary numbers to the decimal. Are you getting any doubt? This one?
No, sir.
This one?
No, sir. No, sir.
Okay.
Second one is what? Decimal to binary conversion. So what happened? You know already. There are two particular, any numbering system, there are two particular parts, integer and fractional parts. I am talking about not a properties, I am talking about two parts. Okay. So when we are talking about two parts, that time what happened? It is one is integers, one is fractional. So what is the rules of when we are converting decimal to the binary conversion? For the integer part, see here, repeatedly divide the given number by 2, because we are converting, our main objective is that, our main purpose is that we are converting to the binary number. So we can use the base of that conversion binary, the conversion number. Okay, base of the conversion number. So our which particular number is the conversion number? Binary number. And what is the base of binary number? Binary number base is 2. And after that, see here, go on accumulating the remainders. We are accumulating the remainders such that the numbers become 0, until the number become 0. Then when it is not a 0, this particular process is going on. And we can record the remainders. Okay. And arrange the remainders in reverse order. Remember, this one is very important. Arrange the remainders in reverse order. Okay. This is we are doing in the integer part. Now, what is the fractional part? Fractional part something different. Okay. Repeatedly multiply the given fraction by 2. And the before fractional part, some particular integer parts are coming. It is maybe 0 or maybe 1. We can record this one. Okay. And if integer parts is 1, that means what? We can solve it off. Okay. That way we are going. And when it is 0 and some 0 is coming, and when we are multiplying any numbers, when we are multiplying with 0, that time what happened? Obviously it is 0. That time what happened? We can stop. We stop there. Okay. Now what happened? Remember, when we are talking about the fractional part, the fraction part, arrange the integer part in the order they are obtained. But remember, here we are not using any reverse order. So if we are getting one particular one, that time what I maintain the sequence. We are maintaining the sequence. We are not going the reverse order. So based on this, suppose we are taking one particular example. See here. Suppose our decimal number is 245, and we are interested to convert 245 to the binary numbers. Now, based on this particular first rule, because 245 is an integer part, that time what happened? We are dividing by 2, because base is 2. See here, 245 when we are dividing 122. So when we are multiplying 2 with 122, that means what? It is 244. How many remainders are required? Only one. So here in the right hand side, dot dot dot, I am using 1. Again 122, I am dividing 61. So 61, when we are multiplying with 2, that time we are getting 1. There are no remainders, so it is 0. So again, what happens? 61, we are dividing by 2, we are getting 30. Because when we are getting 31, that time what happens? It is more than 61. So we can stop with 30. So how many remainders are generated? Only 1. 215, when we are dividing 30 by 2, that time what happens? We are getting 15, and there is no remainder is generated. So it is 0. So that way we are going. After that, see here, when the last portion, when we are using 3 divided by 2, that time what happen? Only 1 is generated. So 2 into 1 is 2, and remainder is 1. We cannot go 2 into 2 because 2 into 2 is greater than 3. So 2 into 2 is generated 4. So what happen? We can stop here. Now what happen? What is the next process? Next process is that arrange the remainders in reverse order. So we are coming from top to bottom, and reverse order means what? We are counting from bottom to top. So what happen? We are starting all the ones. So how many ones from bottom to top? So 1, 1, 1, 4 ones are there. 4 numbers of ones are there. So 1, 1, 1, after that 0, 1, 0, 1. Okay. And when you are getting this particular binary number, you can cross-check, multiply it with power of 2. That time what happen? Automatically you can get 245. So decimal number means what? We are interested to convert decimal number. So here I am writing within bracket 245 base 10 equal to 111. And but remember, when we are reading the binary numbers, then don't follow from right to left. You can follow left to right. 11100101. Are you getting my point?
So I have a question.
Just a minute. Just a minute.
Yes, sir.
Yes.
So yeah, in this slide, the number becomes 1, and in the previous slide you said that you need to continue until the numbers become 0. Here the numbers, like after being divided again and again, becomes 1, but here it said 0.
Yes. Now what happened? Yes, this is the yes, you're correct. You are also correct. Now what happened? If you are, this is because this one we are writing. We are doing by Handique. Okay. So what happened? If you are exactly, yes, this one something is missing here. If you are follow this particular rule, that time what happened? Again you can using the 1, you can divide it by 2. Are you getting my point? Again, what happened? One particular portion I am not writing here. Again, if you are 1 divided by 10, that time what happened? It is coming again because 1 is less than 2. That means no remainder. So whatever in the rule of the mathematics, that means if this one is the number, the divided number is less than the which particular number we are dividing, that time what happened? We are same number. It is representing as a remainder. Are you getting my point? So what happens if you are using that particular one? Suppose if you are using this way, just a minute. If you are suppose this way, if you are using, okay. Now it is okay.
Okay, sir.
Hello?
I see. Yes, I understand.
Now you are getting?
Yes, I understand.
So it is same. The earlier method
Yes,
also
yes,
correct.
yes.
The right hand side method also correct. This one is method also correct. The same thing it is doing. So what happened? This way we can representing 245. Okay. And after that 128, the same thing we are doing. So how many before after 1? That means how many 7 numbers of 0 is required? 1, 2, 3. So 2 to the power 0, 2 to the power 0, 2 to the power 0, 0, 1. The weight is 0, 1, 2, 3, 4, 5, 6, 7. Only 7 position bit is active. So 2 to the power 7 into 1 means what? It is 120. Okay. So this way we are converting to the decimal to binary number. But when we are going to the fractional part, it is see here. Suppose the numbers we are interested to convert 0.634 by this is the decimal number. We are converting to the binary numbers. That time what happened? We are according to the rule, but repeatedly multiply the given fraction by 2. Okay. So we are multiply this one, and after that, what is the rule? It says that accumulating the integer part 0 or 1. So here, see here, before the fractional part, I'm using the color is red color, dark red color, 1.268. So again, what I mean, we are considering it is 1. So again, we are considering the fractional part to 0. Only fractional part 0.268 into 2. That time, what I mean, when we are multiplying 0.536, and we are recording the earlier before fractional part, we are recording here 1. Okay. Again, what happened? 0.536 into 2. Again, we are going. This particular portion is going on. But remember here, see 0.288. So this particular process is going on. So I'm writing here dot dot. But in this particular case, 10100 is enough, because what happened? 0.288. Again, you are multiplying. Then again, you are getting some particular 1 or maybe 0. But what happened here? We are not using any reverse order. Just we are whatever the numbers are appeared, we are maintaining the sequence. So here it is top to bottom. So here I'm using 101000. So 0.10100. This way we are manipulating. And when you are multiplying something again, some particular 0 again it is repeating. That time whatever you can stop. 2 and 3 zeros are repeating, then you can stop. That means you can automatically know that after multiplying, that means no required to multiply, because all the integer parts is appears as a 0. Are you getting my point? Are you getting my point?
Yes, sir. Yes, sir. Yes, sir. Yes.
Yes, sir. Yes, sir.
Okay. So what happened? 0.634. We are writing 1, but remember, don't write 00101. This is the reverse order. Then all the things are wrong. So when we are manipulating with the fractional part, always maintain the order. So from top to bottom. That means 10100. But when we are considering the integer part, that time what happened? We can follow the reverse order. So I am using this particular symbol, the arrow symbol, from bottom to top. Okay. So we are using reverse order. So this is the conversion of decimal to the binary conversion. Okay. Thank you. Today, actually, I have some other work. So today, although today is the 2 hours class, so yes, tomorrow I will manage that particular class, because tomorrow class is 10 to 11. So I will start my class from 9 to 11. Okay. And this particular many examples. Okay, decimal to binary conversion, binary to decimal conversion. You will collect from the textbook. Many solved and unsolved problems are there. You can study that particular. You can practice that particular solved and unsolved problem. And if any doubt, then we'll discuss in the next class. And tomorrow we'll discuss more details about the other binary number system. Okay, thank you very much. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.